scientists present new explanation for the dark side of the moon's strange asymmetry, according to new reports. Prior to the 20th century, astronomers believed that the dark spots on the visible side of the moon were dried up seas and oceans. The scientists assumed that the far side of Earth's natural satellite, our moon, was covered with the same traces, but in the end both assumptions turned out to be totally wrong. Scientists from Earth Life Science Institute at the Tokyo Institute of Technology, the University of Florida and Carnegie Institution for Science, Towson University, NASA Johnson Space Center, and the University of New Mexico have presented new clues about the way the moon gained its near and far side asymmetry. They don't look at all like each other, according to the website Eureka Alert reports. According to the researchers, the heterogeneity of the lunar surface is explained by uneven distribution of substances of KREP group, KREEP. KREP is short for rock enriched in potassium, the symbol for K. K is the symbol for potassium. Rare earth elements, REE, which includes cerium, dysprosium, erbium, europium, and other elements which are rare on Earth, and phosphorus, chemical symbol P, which was associated with the Maria, the scientists explained. And according to Lonville, the evidence for these kinds of non-symmetric, self-amplifying processes might be found in other moons in the solar system and may be ubiquitous on rocky bodies throughout the universe. Now, these substances were found in lunar rocks brought to Earth by American astronauts. The researchers analyzed the results of observations, laboratory experiments, and computer simulations, and they concluded that the heat from the radioactive decay of these elements melted the solid rock, creating craters on the lunar surface. So it was not lunar impacts from celestial rocks, but it was from the radioactive decay of these elements. That's totally different than what we've been told so far. They said now these elements were distributed unevenly on the surface of the satellite, our moon. On the visible side, according to scientists, the rocks were enriched with radioactive uranium, potassium, and thorium, which is why more craters formed there. This is totally different, isn't it? This is because of the relative lack of the erosion process. The moon's surface records geological events from the solar system's early history. In particular, regions on the moon's near side have concentrations of radioactive elements like uranium and thorium, unlike anywhere else on the moon. Understanding the origin of these local U and TH enrichments can help explain the early stages of the moon's formation and, as a consequence, conditions on the early Earth. This is what Matthew Lenville of Earth Life Science Institute, ELSI, stated. He says the evidence of this kind of non-symmetric, self-amplifying processes might be found on other moons in the solar system and may be ubiquitous on rocky bodies throughout the universe. So it's not impacts, it's radioactive decay. Could that also be taking place on Earth? What can I tell you? Please tell me what you think. Leave your comments. Thank you. This is on Sputnik News. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.